Hello, I'm Ivan Fedyanin, and today we will continue our dive into the topic of database replication. And today we will learn about different ways of transmitting replication streams from leader to follower. As we discussed in previous video about leader-follower replication, we have a leader and a follower, and leader constantly transmits changes to the follower, and it appears that it can do it in several different ways. So this time we will consider 5 different ways of how to achieve this replication, and basically on this picture the difference will be that those red rectangles with question marks, they will be different with each different method of replication. Let's start with statement-based replication. Basically, when something is changed on leader, it means that client executed some command or statement on leader. And the obvious idea of replication, if we could just transmit the same command from leader to follower. In that way, leader just has to log all statements which are executed and then transmit that log to follower. Let's look at the example how it could work. Let's consider a very simple example. Assume that we have a booking system which allows us to schedule meetings and add participants to those meetings, and it will be stored, for example, as 2 relational tables. First one is table meetings and second table is participants. So meeting table, it has just some meta information about the meeting, like its ID, who created it and when it will happen, and the topic. And the participants table, it will just link participants with the meeting. So basically it will contain meeting ID and user ID. For simplicity, in our case, instead of user ID, we'll just wrote usernames here in the table. Now, in our example, user Bob creates a meeting called review, and it schedules it for February 1st, 25, and then it adds 2 participants to that meeting, Alice and Eve. This all happen on leader-follower system, and in order to create such meeting, Bob needs to execute 4 commands: 3 inserts, 1 into meetings and 2 into the participants, and then commit message. And with statement-based replication, we just need to transfer the same 4 commands to follower. So we can see it on the screen. So we have statement 1, 2, 3, 4. And those statements are exactly the same which were sent initially by client to the leader. And when follower applies those statements, it will get to the same state as the leader. So basically our task of replication was achieved here. This schema is very simple to understand and it has some benefits. So first is that the replication log is very high level because it contains statement. So usually it's not a problem if, for example, leader and follower has different versions. For example, leader could have some newer version and the follower could have older version. But SQL statements, it's not likely that SQL standard will change between those versions. So it's high level enough not to worry about compatibility issues between leader and follower. Second benefit is that replication log is very compact. For example, imagine if we had some update of a table with 1 million records and we just updated all of them in the same command without any where clause. And it would be just one command, like update table meetings, for example. And in order to transfer all of this to follower, we just need to send one text command. And another benefit of this approach is audit. Basically, in order to achieve this replication, a leader needs to keep log of all commands which are executed. And this log could be just reused for audit purposes. However, this technique has some very serious drawbacks, and most of them related with non-deterministic comments. For example, our comment it could contain some non-deterministic functions like now, for example. Bob, for example, when Bob created a meeting, he could specify the date not as absolute date, like 1st February, but he, for example, might have used function today. And today executed on leader is one date, but for some reason, if replication got delayed for one day, though it's very unlikely, but why not? Then on follower, the same function today would be resolved to different date, and it would lead eventually to the just drift of state of follower from the leader, and our system will become not consistent. It will not be even eventually consistent because there is no any mechanism to just reconcile those changes. Another drawback is related actually to the same non-determinism is, for example, statements which contain some auto-incremented counters which are kind of non-deterministic when executed in parallel. They have to be executed in the same order on followers, and it's not always possible. And if they're executed in different order on leader and on followers, or for example, they could be executed in one order on one follower and in another order on another follower, and thus those two followers or follower and the leader will end up in different state. And finally, some statements could cause side effects. For example, we could have triggers which react on inserting or updating data, and those triggers could have its own non-deterministic statements and could cause, for example, inserts into some other table, auto increments of some counters, and so on. So basically, it can become a mess. So overall, the drawbacks are quite serious, and they are so serious that purely statement-based replication is almost not used in real database systems. It was used in MySQL until version 5.1, but later it was replaced with another replication method. In order to deal with challenges of statement-based replication, another replication method called logical replication, or also known as row-based replication, was suggested. By the way, this video is also available in the article, in the text format, which you can see on the screen. It's my website, fedyanin.com, and this article with all pictures, tables, links, references available here. So if it's more convenient for you, or later if you want to go through some specific points, you could just look in the description of the video. There will be a link to my website, and you can find this article there. So let's get back to our logical replication. It solves major drawback of statement-based replication, which is non-determinism. And it solves it by replacing comments with specific changes to specific rows. Instead of sending comment, which for example says update record and set some date value to now or today, we just on leader we just evaluate this comment, get the specific value, and then send this specific value to the follower. Let's just see again a simple example with our system of booking meetings. Here again Bob creates two meetings, one called review, another called planning. For this he inserts two records into the database, and both meetings are scheduled on February 1st. But then Bob realized some mistake during determining the meeting date, and he updates and sets the date for both meetings at the same time for 3rd of February, and then he just commits. Let's see what will be sent from leader to follower in that case. We see that first two lines here It's just records corresponding to inserts into the specific rows. So here we don't say to follower insert into meeting that values. We just say that the record meetings with that specific values was inserted on leader. So you just have to apply the same row on your local storage, and follower does that. Up to now, it seems very similar to what we have seen previously with statement-based replication. But let's see update statement, which is very different. So we have one update statement which updates two records at once. And here we see two corresponding rows are sent, two corresponding messages are sent to follower. They are independent, and one is just updates one row in the meetings table, and another updates another row in meetings table, and we just provide specific values for those rows and then commit message, of course. This method has several important benefits. First, determinism is not a problem anymore because we don't send comments, we just send values. So values are always deterministic. Secondly, because we just send logical content of rows, it's not very dependent on internal structure of how data are stored in the database, on the underlying database engine. And thus, it's usually not a problem to have different versions of a leader and follower, for example, when we are doing some upgrades. And the third benefit is related again to the fact that changes are high level and that they represent actual data changes, and that stream of changes, it could be consumed not only by follower, for example, but it could be consumed by some external application for some processing. And this is called change data capture, CDC, when some application could just consume a stream of changes in the database and apply some logic. For example, it can send it to some remote locations, it could store them in some separate database for analytics purposes or whatever. But as usual, as everything has drawbacks, this method has them too. And for our benefits, we pay with some problems. First one is that size of data which needs to be transferred from leader to follower could be really huge for bulk update operations. For example, assume again that we have table of 1 million rows and we just want to update one attribute of each row to some value. And we can just have one command update everything in some specific table without any where condition. So one command will update 1 million rows, and in row-based replication, it will cause 1 million records to be changed, and each of them will be sent to the follower. So we just have a very huge amount of data to be sent. And second drawback is that we can't really send DDL changes that way, which is data definition language, which means, for example, table creations, trigger creations, and changing the objects themselves in the database, because this replication focuses on row changes. But we could cope with those drawbacks and live with them. And quite a lot of systems, actually most systems which are well known, support this method of replication. So it's Oracle, Microsoft, MongoDB, Elasticsearch, Kafka, RabbitMQ, and so you can see all of them here. To be more practical, let's look at some specific example in MongoDB, for example, how it works. And MongoDB, it has a special internal collection called Oplog.rs. It's written here. And this is kept collection. It means that old records automatically removed from it. And basically, when some data are changed on the leader, the information about those changes are written into the Oplog.rs. And then they are just sent to followers and applied there. So, for example, when document is inserted, updated, deleted, when some table is created, or some other change happened on the leader, then it's written into this table, into this collection. And further, I want to show you how exactly it looks. We will do some changes to the data, to our experimental setup, and we'll see what records into the Oplog will be inserted. So first, let's have the same booking system for meetings. But previously we have seen relational examples, and now we'll just adopt it to the document model, which is supported by MongoDB. So basically we will have this meeting document. It will contain topic, organizer, and array of participants. And let's see how it works. In the table below, we have two columns. One is comment, it's on the left. Here there will be comments which I'll execute on MongoDB. And on the right, it will be Oplog records which will be generated by Mongo based on those comments. Initially, we insert first document into this collection with some meeting topic, with organizer and arrays of participants. So we could see here that it was inserted and the object ID was generated for this record, for this document. And let's look what was there in the Oplog. We see actually that this one comment generated two comments. So we can see that operation is create, we have unique ID, we have some description of object which is being created, so it's a collection meetings, and there is an index which is created in MongoDB by default on _ID attribute. This is happening because in MongoDB the collection created implicitly when you insert first document in that collection. And the second Oplog record is document insertion itself. So here it's important that we have this object definition, which contains ID of our object, which is equals to this ID which we had here, which was generated by our insert command. And it has all content of this document. And we can see there is a second object generated. It's related to index on ID field. Next, let's insert second meeting, which is called pizza party. And again, now we can see only one record because collection already was created. So we just need to say that the object was created, and of course index record was added as well. Next, let's try to make an update. We do update many here, and we just add the participant Jim to array of participants of all meetings, because we don't have any condition here. It will update all records which we have, and we see that matched count is 2, modified count is 2, so basically we have updated 2 documents with this single command. And now we see that we have in Oplog we have 2 separate records. One record is update of first object, so we see that operation is update. Here it's what exactly is updated here, and here is update of second object, and it says what's updated in this object. Now let's see how MongoDB deals with non-determinism, and for this we will update one meeting and set some random number to the meeting document. And we'll just use mathRandom function to generate some randomness. And in the Oplog, we see that we have specific value of this random number. So leader evaluated this function, it's executed it, and it has created a record with this number, which then will be transferred to the follower, and follower will use exactly the same number. And finally, let's see, for example, let's delete one meeting and see that it has generated one Oplog record, which has this operation D, which means delete, and it specifies object which we want to delete. So I hope this illustrated this process of creating replication log in logical or statement-based replication. So as you can see, logical replication in general works much more predictable than statement-based replication, but it has a drawback with dealing with bulk updates when we have to send a lot of changes. And there is an approach which is used in MySQL, and it's called mixed replication, which tries to solve this problem by combining together row-based and statement-based replication. Basically, it works like by default it tries to send statements, but if it discovers that statement has some non-determinism or could cause some side effects which are non-deterministic, then it for this specific statement it switches to row-based replication, and in that case it tries to combine the best parts of both of it. But unfortunately, because there are too many options for non-determinism, it's still problematic to cover all cases when we need to switch to row-based replication. And this technique could be buggy and could lead to some unexpected results. So actually, it's not recommended to use. And for example, in Percona blog, there was described a bug related to this replication, which could cause just drift of follower and leader. So in general, for MySQL, it's still recommended to use row-based replication unless we have some very specific reasons to use mixed or statement-based replication. It could be useful in some very specific scenarios, but we need just very well understand if we want to use it, why we do it, and understand all the drawbacks and potential problems.